in this section we're going to look at how we determine the resultant using the graphical method. So the last time we were looking at what's called the component method. So in this case now we're looking at what's called the graphical method. So in the graphical method you have to draw an accurate vector diagram. By accurate we mean you have to use a scale and you have to draw everything to scale. So you need some tools, you need a ruler, and you also need a protractor to measure your angles. So there are basically two ways to solve for the resultant using the graphical method. Alright, so for example, you can say for your scale, you can say let 1 centimeter represent, let's say, 10 newtons. So if 1 centimeter is representing 10 newtons, it means that the length of this particular vector here would be equal to 9.5 centimeters. And then the length for this particular vector here would be 11 centimeters. And you also have to measure this angle here, and you plot them accurately, and you measure the resultant using your ruler. Right, so the two methods that we have, we've what's called the tail to tail method, or sometimes known as the parallelogram method. So you put the two tails of these particular vectors such that they must start at the same point. Then the resultant will be the diagonal of a parallelogram. So if you can check here in this particular diagram here, right, I can simply move the vectors around. Right, a vector can be moved around like this. You can take this vector and put it there. I can take it and put it there. As long as I don't change the magnitude and the direction, it will still remain the same vector. So since you can move this particular vector here, it means I can rearrange these vectors. I can put my vectors like this. So if I do this is called the tail to tail method. If I put one vector on the head of the other like this, it's called the tail to head method. So we have two methods. We've first got the tail to tail method and the tail to head method. So let's start by looking at the tail to tail method, or the parallelogram method. So I have force number 1 here and force number 2. The tails are starting at the same point. So what I need to do here is to draw what's called a parallelogram. So remember, properties of parallelograms: opposite sides are equal and parallel to each other. So if I take this particular vector and then I just duplicate it and place it there, it's exactly the same as this side here. All right. And then I can also do the same thing on the other side as well. I can simply take this, duplicate it, and then I simply place it over here. Then I'll have drawn what's called a parallelogram. Then the resultant will be the diagonal of the parallelogram. So if I draw a vector starting at the tails here up to the heads here, so the diagonal from this point all the way to that particular point there, this would be my resultant of these two vectors here. So this is called the parallelogram method. But of course you'll be doing all this accurately. So you'll be drawing accurate diagrams here and measuring the angles and the lengths of the lines. In the tail to head method, the tail of one vector is placed on the head of the other vector. So the resultant will be an arrow, and that starts from the tail of the first vector to the head of the last vector. So for me to draw the resultant here, I must start at the tail of the first vector to the head of the last. This would be my resultant. So this diagram is just the same, but I have started by drawing the F1 vector here. So whether you start with the F1 vector or the F2 vector, it doesn't really matter, because you will have the same resultant at the end of the day. There is our resultant. Our resultant is the same here. The direction might be slightly different because we are measuring, this one you're measuring from F2, this one you're measuring from F1, so you'll have slightly different directions here. This is just generally how you find the resultant using the tail to head method. So we'll try to look at an example. We'll just use this vector diagram, this situation here, as our example. And we'll try to use both methods to see how we do it. Alright, so yeah, we have this particular situation here. What we want to do now, we want to try to use the tail to head method first. So we have our situation here: force number 1, which is 95 newtons, force 2, which is 110 newtons. Force 1 is 47 degrees to the horizontal, and we're going to use a scale here, 1 centimeter representing 10 newtons. So what this scale means is that the length of F1 would be 9.5 centimeters, and then the length of F2 would be 11 centimeters. We need our protractor and we need our ruler. Alright, so what I need now to do, I need to draw the F2 vector first. Alright, and then I can draw the F1. You can start with the F1 or the F2, it doesn't really matter. But I'll start with this one here because now it will make it easy for me to draw my F1 at an angle of 47 degrees. Okay, so I'll draw my F1. So the length of this F1 is 11 centimeters. So I must start from this particular point here all the way to 11 centimeters. Right, so up to this point. Alright, so this is my F2 vector, which is 110 newtons. Alright, so next up I need to draw my F1 vector. So my F1 vector is going to start here at this particular point, right, at the head of this vector, but it must be at an angle of 47 degrees to the horizontal. So 47 degrees, if I can mark it here, this 10, 20, 30, 40. So 47 is somewhere here, so that particular point there. Right, so I then remove my protractor, and what I'll do is I'll simply connect these two lines together. So this point connecting with that dot that I've drawn there. So take your ruler, just line up the points there. There we go. Right, something like that. So now I need to draw F1, but then F1 must be 9.5 centimeters. So I'm going to start here. My 0 point is there, 9.5 centimeters. Okay, let me just twist it a little bit. Right, 9.5 centimeters is somewhere here. Okay, so I'm going to draw from this particular point right up to, no, that's, yeah, no, that's fine. Yeah, up to this particular point here. So this is my F2, F1, sorry. Okay, this F1, which is equal to 95 newtons. Okay, pretty cool. So next up, I just need to draw my resultant. So my resultant is going to start from the tail of the first to the head of the last. Alright, so take your ruler and you connect those 2 points. Alright, so from this point up to that particular point. Also from here, my resultant is all the way up to that particular point. Then this is my resultant. Alright, and then this angle here will represent my direction. So what I need to do now is to measure the length of this resultant. So from this particular point here up to that particular point, I think it's about 19 centimeters. Yeah, so my resultant here is 19 centimeters. So 19 centimeters, if I multiply it by 10, I can then say my resultant is equal to 19 centimeters, which is equal to 190 newtons. Right, next up I need to measure the angle. Alright, so okay, I'll just do this and see what angle I have here. Yeah, about 20.83 at 20 point, let me just say 8 degrees from the horizontal. Right, there's my conclusion there. All right, there's my answer right here. So this is the tail to head method. Let's try to do the tail to tail method and see if we get the same answer. So the length of this line should be 9.5 centimeters. the length of this vector here should be 11 centimeters using my scale. I'm going to start with the F2 here. So from here, I draw a straight line, 11 centimeters. This is my first vector, which is F2, 110 newtons. All right. And then from there, I need to draw F1. Now F1 is making an angle of 47 degrees. All right, so 45 is here, 46, 47. Okay, so you can never be 100% accurate. All right, so 47 is here. So I just put a point there. I remove my protractor. Then I must now join just this tail and that particular point. If I draw a straight line there, I will have constructed a 47-degree angle. So from here, I need to draw a line that is 9.5 centimeters long. So I'm starting here. I draw a straight line up to 9.5 centimeters. So this is my F2 here, which is 95 newtons. All right. So now next up, I now need to complete my parallelogram. So I just need to duplicate what I did here. So right, I'm going to start with this particular force here, force 2. I'll just put my protractor there and draw a 47-degree angle again. So I need to construct it. So from here, I just mark that point. I remove my protractor. I put my ruler. I know that's 47 degrees. So I have to draw a line that is the same length as F2. So this is my F1. Oh, this is my F1. So I need to draw a line that is exactly the same length as F1. 9.5 is ending there. Alright, so from here, draw a straight line. Alright, that's fine. So this is my first one, right, which is the same there. And then I now need to complete the other side. So the side I don't need to measure anything. I just have to connect the two heads there. But I just need to make sure that my line, my ruler is just horizontal. So I just have to connect these 2 points. All right. So this is my vector right here. And then next I now need to draw my resultant. So the resultant is just going to be a diagonal from the tails of the 2 vectors to the heads of the 2 vectors. Alright, so from there, this will become my resultant, right? So this is my resultant here. So what I need to do now is to measure the length of my resultant. Let me just try to use this slider here. Let me see, let me just say 18.9. Alright, so the length here is 18.9 centimeters. And then the angle. So now you can now choose here which angle you want to take. Either you can take the, so let me just take the angle between these 2 here. Right, so I'm getting about 21.2. So this particular angle here is 21.2 degrees. Alright, so I can now write my conclusion and say the resultant is equal to 18.9, so that's 189 newtons at that's 21.2 degrees from the horizontal. So that's from the horizontal force, and then that becomes my conclusion. Alright, so you can also decide to take this particular angle here, the angle between the your resultant and F1. right? This particular angle is 25.7. So another conclusion that you can reach, you can say, okay, you can say my resultant is equal to 189 newtons at 25.7 degrees from F1, and then just like that you've reached your conclusion. So this got an accurate construction of your diagrams.